Hello, I'm Nicolette Pomba-Van-Zyl, editor of ESI Africa, and I'm at the African Utility Week studio today with Stephan Padlewski, who is the marketing manager of DuPont. Welcome, Stephan.
Thank you.
We're going to be talking about the solar PV market specifically. And my first question to you then is, the global trends that are happening around that market space are really growing exponentially. But what is happening in Africa? Is Africa keeping pace with those trends?
Well, the short answer is yes. So just moving to the global market, between 2015 and what we expect this year, we expect the market to keep growing at a pace of around 15 to 18%. So last year, globally, the market installed something around close to 50 gigawatts of system all around the world, driven by three key markets: China, Japan, and the US. Capturing probably 60% of the market. Now in the world context, so 15-60% growth we expect this year, so the market may be short of 60 gigawatt this year, so adding another 10 gigawatts. So it's quite remarkable what this industry is, the path this industry has been on over the last couple of years. Now in this scheme, Africa is an emerging market, of course. Now the pace of growth is actually higher in this geography. So we expect the market to be around 1 gigawatt across Africa regions, and to probably double next year, and then to add another gigawatt moving to for the following year. So the growth will be actually much higher in this part of the world. Now, of course, starting from a smaller base, so there is a lot of catch-up to expect for this market over the coming years. So the future is certainly bright for Africa market.
And we're seeing quite a bit happening in South Africa as well. And then looking also at residential and commercial rooftop PV, that is also a growing trend. Right. So if somebody is going to invest in that, it's quite a considerable investment. What do you advise them?
Well, rooftop PV is a segment on its own. So as you know, the market is divided in two segments: the ground installation, which has been the core market segment, certainly looking at South African market. Now the rooftop market is a growing segment as well. Now, rooftop is a fairly complicated market segment in itself. To start with, you are dealing with a much smaller installations, but far many more. The end user is basically the prosumer, the house owners, or small commercial building owners who may want to retrofit the rooftop with some PV installations to add some power capacities. Now, some of the challenges, there are a couple of them. It's not as a straightforward market segment as a ground installation would be. To start with, the stress environment in the rooftop is typically higher than on the ground installation. So a panel or PV system operating on the rooftop is exposed to a much higher thermal stress, for instance. So if you don't watch out carefully how you design, how you pick up the component, and how you install the system, your PV installation may degrade faster than a ground installation. So you have to watch out how the system is installed. Not saying that it's not going to work, but you have an extra precautions to look at from an investor standpoint.
Right. And the other thing to look out for is the maintenance of that. I know that for instance, the V&A waterfront, one of the things they didn't consider was the amount of birds that are then nesting and making a mess on those modules.
Absolutely.
What is it that people should take into consideration around maintenance?
Yeah, it's really start with a good system. So the system needs to be designed to be robust in these particular environments. So to start with an installer, I mean, if you are a homeowner and you want to select, you have to watch out who you are selecting. As an installer, somebody with a track record and experience is something really very important to do. I talked about the component themselves being built to handle additional thermal stress. Now, on the maintenance standpoint, you have basically people forget that the system, is meant to produce power. So you need to watch out your system. It's not like build and forget for 20, 25 years. So you really need to pay a special attention to your system. So the first thing to do is to watch out the power output of your system. If you see some catastrophic degradation of the power output in a sunny day, that should raise a flag, and that something wrong may happen. So there are two basic dangers, something particularly to watch out on a rooftop installation, and they are both safety related. The first one is what we call the hotspot. You talked about birds. Now the birds in itself, are causing basically a spot that we create some shadow partially onto the panels. Now what is happening as a result of that, you actually will create something called a hotspots. Hotspots, the cells affected, shadowed, actually will generate more heat than the other cells, because the peak currents of that particular cells, shadowed cells, will be lower than the rest of the cells around that. So the other cells will keep pushing currents through that particular shadowed cell, and because the peak current is lower, the cell starts producing heat. So that's really what is happening. So that particular, in this particular case, it's pretty obvious what you should be doing. Clean the panel when that happens. So hotspot is a potential danger. It can create some extra thermal stresses and degradation to the panels. And in worst case scenario, it can be represent a fire hazard. So that's one thing you have to be very careful. The second issue is you may want to watch out is related to the leakage of currents that may occur. And but there are some very easy fix, or at least way to detect it through the inverters. So basically, bottom line is watch out your system. It can operate very safely for 20, 25 years, but you need to pay special attention as a system owners. Watch out how your system produce. Any degradation, raise the flag, call the installers, and conduct a survey to detect the root cause of the problem.
That's very good advice. And with the commercial building wanting to put rooftop on, they need to know that somebody needs to be assigned to take care of that installation.
Absolutely. Yeah.
And you spoke about the prosumer. This is something that is coming up time and time again in terms of a potential risk to utilities and municipalities, changing the dynamics of how power is supplied and consumed. What do you advise for the utilities in that space?
Well, I mean, there will be constantly a fight between utilities and the prosumer themselves. And the prosumer wanted to gain independence, basically, and access to a cheaper electricities and gaining securities as well. There are certain countries, as you know, around the regions, where the power supply is not steadily available. So you need a backup for yourself as a power consumer. So for yourself. So there will be always be a fight between the utilities and the end users from that respect, because as a self-producer of power, you basically bypass the system, the utilities system. But basically, I think in many cases this has to be resolved. You can see that the flip side of the coin is you don't necessarily need from a utility companies to deploy a tremendous investments throughout the grid, for instance, to meet the demand of the consumer. So there is probably a win-win sweet spot to identify, but it's not yet done today. And it's really a great deal of discussion between the utilities and the model where you and I, as a consumer, could deploy our own system to produce and self-consume the power we generate, bypassing the system.
One of the things that we need to take into consideration is that change will always happen.
Absolutely.
And you need to keep pace with what is happening in the market. And that brings us to research and development around solar modules. What is happening in that space? What can we look forward to in another decade?
Well, there are really 2 or 3 key areas, the way we see the development happening, at least in the photovoltaic industry. The first one is the efficiency improvement of the panels. Today the conversion efficiency of photovoltaic panels is roughly around 18, 19, even 20% range. So the amount of light you get, you convert only that amount into electricities. Now, of course, going into a higher figures, 22, 25%, actually is a way to reduce the total system cost, actually, by making a much better utilization of all the components used for PV systems. For the same amount of component, the amount of panels, the cabling, the mounting system, the system will produce more power. So mechanically, you reduce the cost of the electricity. So that's a #1 priority for the industries and one of the key focal points for the industry, the R&D aspects to keep working on. The second aspect is the durability aspects. We talked about the rooftop installation being a very stressful environment. So it's very important to the industry to develop and design a system component that are more reliable and durable than certain components today, operating within a given stress environment. So you have to make them extremely robust, to make them durable. At the end, the LCOE, you know, the levelized cost of energy, takes into account not only the system cost, but the power output over the actual system lifetime. So the higher the figure is, the longer the lifetime is, the lower the cost of the electricity, the solar electricity is. So making a longer lifetime is one of the key imperatives also for the industry. And the last is to look more holistically around the PV system. Making a total installations, lowering the cost of installation, for instance, by avoiding duplicates in component. For instance, between the mounting system and the module itself, you have a duplicate of components. You know, taking the frame, for instance, which is designed to provide some mechanical rigidity to the panels, and the mounting itself that provides also some mechanical reinforcement. So there is a duplications of functionality that can be eliminated if you have a more holistic approach for designing the system. So those are the three areas of improvement where we will see.
So those are three very exciting areas that we can look forward to in terms of what that solar module will look like in 10 years' time, or even sooner.
Yeah.
And lastly, I want to talk about the rate of rural electrification in Africa. It is a predominant topic here at African Utility Week. And I know that in terms of solar hybrid systems being a potential solution, what are your thoughts around that?
Well, we all know the numbers. There are about 600 million people across Sub-Saharan Africa who do not have access to electricity. So that's really a formidable challenge. You know, how we achieve that, how we can deliver cost effectively electrical power to that vast communities across the continent. So we talked about the diesel. So there is today a kind of grid or mini grid established by the diesel generator. So one of the questions is whether we should not leverage that particular source of power and to add on some PV system. Now, doing that, and that could be step one, you know, to answer the question, how can that be done? The rationale around the hybrid systems, to take that as an example, is a way to actually lower the cost of electricity. You know, diesel generator, the cost, the LCOE for a diesel generator is actually pretty high. The cost of energy is very high. We're using a diesel generators. Why? Because you have the problem of the gasoline. I mean, you have to bring the feedstocks, has to be conveyed in situ and to fuel the power generators. So that brings the cost of electricity to be very high, without talking about other issues like stealing that can occur across the supply chain. So the problem is how we can lower the cost of energy. So if you talk about diesel, you are at around $25–30 cents per kilowatt hours. Now a PV system, on the other hand, today with the current cost environment, you are probably at around $10 cents on a kilowatt hour basis. So you are probably at around a third of the cost, producing power using solar energies. Now the problem, as we all know, with the solar energy is the intermediacy. So we have sun, we produce energy. We don't have sun, we don't. So you need basically initially, you could envision a system combining the two technologies, during the daylight using solar as a source of energy, and during when you don't have sunshine to use the diesel as a backup. And when you look at the mix of the cost of the two sources, you basically you can reduce quite significantly the cost of energy by a factor of probably 2, and even more depending upon the mixture that you are going to use. So that could be a first step. To approach this market. And yes, the opportunity is also in the gigawatt scale very easily, and could be a first entry point for the industry to address this particular off-grid market.
So in terms of solar PV, we've got a lot to look forward to in Africa with that growing market, with a lot of potential opportunities, and never mind the risk, the opportunities are there waiting.
It starts with the demand. The demand is here, so the market will be here for the long run. And yes, Africa is perceived to be the next very large market around the globe. You know, we talk about China today, we talk about the US, we talk about Japan. Aging market basically from that standpoint. The next big one, in my eyes, is Africa. So
what a positive note to end on. Thank you for watching. I'm Nicolette Pomba-Van Zyl, coming to you from the African Utility Week studio.